so here we have a couple of objects on slopes, and you can see that the slope has the angle. We've got the weight of the object, okay, and we're going to try and do some vector analysis of these. So the first thing to say is that the weight of this object is going to act from the center of the object, and it's going to act vertically downwards, and we know that that's 15 newtons. Okay, now we're going to take that 15 Newton force and we're going to split it into two components. So we can split it into two components, and those components will form any vector. You can split it into two components that will form the sides of a parallelogram. So for this weight here, we will split it into two components, one of which will be down the slope. So there's this component here down the slope, and the other will be perpendicular to the slope like that. Okay, so if we redraw this situation over here, we've essentially got the weight. There's your 15 newtons weight. Okay, so that's your 15 newtons, and we can split that into two components, one acting down the slope and one acting perpendicular to the slope. Okay, and they're going to be at right angles to each other. And you could draw it on this side as well. So perpendicular to the slope, parallel to the slope. Okay, so this vector can be split into two components that form the sides of a parallelogram. Okay, now by looking at this, we can work out that this angle here is the angle between this. So essentially the weight here forms a triangle, okay? And this triangle has got a right angle there. So a right angle there, we know that's 30 degrees. So this angle here must be 60 degrees because the angles in a triangle have to add up to 180. So 90 plus 30 makes 120, plus 60 makes 180. So that angle is 60. That angle there must be the same because this is along the slope and this is the weight. So we know this angle here is 60 degrees. And if that's 60 and that's 90, this angle here must be 30 degrees, okay? So that angle there must be 30 degrees. Okay, so to work out the components down the slope and perpendicular to the slope, we can now use trigonometry. Now, if we look at this setup here, this is the weight. This angle here on this side from similar angles will be 30 degrees, and this angle here will be 60 degrees, okay? So to work out the component down the slope, this component down the slope here, we're going to look at this as a triangle. We're going to use this 30-degree angle here. We're going to say that this is the opposite, this is the hypotenuse, and this is the adjacent, okay? So to work out this opposite here, the component of the weight down the slope, we can use sine. Okay, so this is the opposite to the 30-degree angle. We're using that angle. We're not using this one at the moment. We're using the 30-degree angle. So sine of 30 is equal to the opposite over the hypotenuse, and the hypotenuse is 15. So this here is equal to 15 sine 30. And if you use your calculator to work that out, 15 sine 30 is going to give you 7.5. So that equals 7.5 newtons. Okay, so 7.5 newtons down the slope. Now, this component here, which is perpendicular to the slope, is going to be equal to 15 cos 30, okay? So 15 cos 30, because it's the hypotenuse multiplied by cos 30 is equal to the adjacent. And in that situation, it's going to equal 15 cos 30, which gives you 12.99, so essentially 13.0 newtons, or 13 to 2 significant figures, like the data was, okay? So we now know that this vector here, this weight, has two components. Down the slope, so along the slope there, it's got a component which is 7.5 newtons, and perpendicular to the slope, like that, it's got a component which is 13 newtons. Obviously, those arrows aren't correct because they're not the right length to represent the magnitude of the vector, but just showing you that we've now worked out the component of this weight that's perpendicular to the slope and the component of this weight that is parallel to the slope. Okay, so onto this one now, same idea. So we'll look at this one now. We know that the weight of this one here is acting down like that. So that's 224 newtons. And as we've shown before, we know that this weight has two components. It's got a component down the slope like that, and it's got a component perpendicular to the slope like that. And the angle between these here is 90 degrees. So that's 90 degrees. Now this angle here is 20. So if that angle's 20, then this angle here, which is the same as this angle here, because that is lined up with the slope, this angle here must be 90 plus 20 obviously makes 110, so that must be 70 to make up the 180 degrees. So if I call this angle here theta, then theta equals 70 degrees. Okay, so that's 70 degrees. And what you'll notice then is that this angle here is obviously 20 degrees, because 70 plus 90 plus 20 makes 180. Right, so we're going to work out the component down the slope and the component perpendicular to the slope. So if we redraw it over here to perhaps make it clearer, so we've got, that's our 224 newtons. Okay, and then we can split this into a component down the slope and a component that is perpendicular to the slope. Okay, so down the slope, perpendicular to the slope, and that angle there is 90 degrees. This angle here is 70. This angle here is 20. Okay, and again we could draw it on equally on this side. This is the parallelogram rule, that any vector can be split up into two components that form the sides of a parallelogram. Okay, so this angle here is 20. This angle here is 70, so 20 plus 70 makes up the 90 degrees there, and that's 90 degrees, okay? So that's the component of the weight that is perpendicular to the slope. This is the component of weight that is along the slope. Okay, so to work these out, so again, we're going to use this 20-degree angle here. So the component that is perpendicular to the slope, this is the hypotenuse, this is the adjacent, this is the opposite. We're not using that 70-degree angle, we're using the 20-degree angle. So this component that is perpendicular to the slope is going to be 224 cos 20. And this component here, so let's just work that out for a moment. So 224 cos 20 gives you 210. Now, the component that is parallel to the slope, so that is along the slope here, is going to be opposite of the 20-degree angle. Okay, you can see that here it's opposite the 20-degree angle, opposite that 20-degree angle there. All right, and to work that out, then you're going to need to use sine theta. So 224 sine 20, which equals 76.6 newtons. Okay, so there we go. We've worked out the component perpendicular to the slope, the component parallel to the slope. So parallel to the slope, we've got 76.6 newtons, and perpendicular to the slope here, we've got 210 newtons. Okay, so that's how we do those.